Everyone, in this video let's discuss about the 1:4 demultiplexer. So you can call them as 1:4 DEMUX also. As the name suggests, there will be one input and there will be four outputs. Four outputs and one input. Now let's represent them in the block diagram. In the block diagram we will just represent what are the inputs and what are the outputs in this circuit. So four number of outputs and only one input. Let me call the input as I and I am having four outputs. Let us call them as y0, y1, y2 and y3. Here I am having single input which must be passed through any of these four outputs. So which output line will be selected will be decided on the selective lines. So here comes the concept of selective lines. So take the number of outputs, that is 1:4 now. So 4 number of output. How you can represent 4 using 2 power. 2 power 2 will be 4. So 2 number of selective lines will be used in the 1:4 demultiplexer. Let us call them as S0 and S1. Now if you want to represent for 1:8 demultiplexer means you can represent 8 using 2 power 3. So 3 number of selective lines will be used in the 1:8 demultiplexer, like that. So here another one added element will come, that is enable. When enable value will be equal to 1, that is when enable will be in the on state, then only you can proceed with the operation that you want to do with this circuit. Otherwise you can't proceed. That is no inputs and no outputs will be given when enable value will be equal to 0. So now let's write the truth table. One input will be enable, next S1 and S0. My outputs will be, if you see here, I am having 4 outputs, Y0, Y1, Y2 and Y3. I earlier said that when enable value will be equal to 0, no inputs will be given and no output will be given. But when enable value will be equal to 1, now if we see only 2 inputs are left, because enable value will be always in the on state if you want to get the output. So 2 inputs are selected. 2 inputs means what are the 4 combination? 0, 0, 0, 1, 1, 0 and 1, 1. Now let's assume that when enable value will be always 1, no? So let's leave that. When S1 value will be equal to 0 and S0 value will be equal to 0, the input I will come through the output Y0. So I 0, 0, 0. Like that only. When S1 value will be equal to 0 and S0 value will be equal to 1, the input will come through Y1. Like that only. Now with Y2. Next one with I3. Next one with Y3. Now we completed with the truth table. Using this truth table, we want to write the equation for the output. So first one is Y0, next is Y1, Y2 and Y3. For all of them, let's write the equation. For Y0, if you see here, when I value will be equal, when Y0 is here, see the Y0 column, round where I is there. So I is here. What is the value of E? E is 1, S1 is 0, S0 is 0 and I. So you can write that E, S0 bar, S1 bar and I. Next, for Y1, E, S1 bar, S0, I. E, S1, E, S0, S1 bar, I. Next, here I is there. E, S1, S0 bar, I. E, S0 bar, S1 and I. For the last one, that is Y3, E, S1, S0, I. E, S0, S1, I. Now using this, let's write the circuit diagram. So I will represent the circuit diagram. Enable will be in the on state at all the process. So I will take like this. Next is S0. S0, we are having S0 bar also, so I will be using NOT gate also. Next another one is S1, so in S1 also we are having NOT gate, that is S1 bar is there, so I will be using NOT gate. Enable is over S0, S0 bar, S1, S1 bar, and another one is I, so I will take here itself, enable. So I will take here itself. Now first one y0 is equal to, now first one y0 is equal to enable S0 bar, S1 bar and I. You will be connecting them using the AND gate because in between them multiplication. Next, this is for y0. Next one y1, enable S0, S1 bar and I using the AND gate. This is y1. Next, enable S0 bar, S1 and I. This is y2. Next, last one, enable I, S0 and S1 using the AND gate. This is for y3. So this completes the 1:4 demultiplexer. If you have any doubt regarding this topic, please do comment below, and the video link of all the topics of digital logic design is given in description. You can access it. If you liked the video, please subscribe and support us because your one support motivates us to make more engineering related videos. Thank you.